Hello everyone. So today we are going to see about the constants. So why we use the constant, let us see. So first of all, if you have a table called a student, and this will have the column student ID, student name and average. So here we are not using any constant. So we are able to insert the duplicate data into this table. So here you can see duplicate data is allowed here. Next we are able to insert the null values into this table also. So null also allowed. And so let's suppose average is should be not be greater than 100, but we are able to insert the average greater than 100 also. So all this data redundancy problem and inserting the null values and duplicates and the invalid values, so to avoid this we use the constant. So let us see the what are the constants. So constants are used to restrict unwanted data into the table. All databases are supporting the following constants, that is this unique, not null, check, primary key and foreign key. Foreign key is also known as reference key. All databases are supporting the following two types of methods to define the constant. So two types of methods are there to define the constant. First one is at the column level and second one is table level. So column level, in this method we are defining the constant on the individual column, and in the table level in this method we are defining the constant after all columns are declared. So we'll understand by the example. So let's suppose we are using this first constant, that is unique. So on this unique we'll see this constant. So in this constant what will happen if we apply this declare this constant on the column. So on the whatever column we are declare, in that column duplicates will be not allowed, duplicates not allowed, and null values allowed. So in the unique constant what will happen, duplicate value are not allowed but null values will be allowed. So let's see example. So here I am using SQL plus prompt, you can also use, or you can use SQL developer. So here we will create a table. So let us first of I will see whether the table is present or not. It is already present, so I will drop this, drop table test 01. So it will be dropped. Now clear the screen. We will create table test 01, and I will take employee ID integer, and we have to take this column as unique. So unique employee name and where char 2 of size 10. So let's create this. Created. Now I will insert data, insert into test 01 values 1 comma sam. I will insert here 2 comma sam, and if we insert here 1 comma ram, select star from test 01. So we have created this table with this unique constant, and this unique constant is only declared with this employee ID. So what we have discussed, in the unique the duplicates are not allowed. So first we inserted 1 sam, second we inserted 2 sam. So we are not getting any error while inserting to this, but while inserting this 1 ram we will get a error, because 1 we are declare this employee ID unique. So in the unique duplicates are not allowed. So already 1 is there, but we are able to we are trying to insert 1 again. So for that reason we will get unique constant violated. But in this case why we didn't get as this sam and sam is same? Because we are not declared here a unique, we are declared unique constant only on the employee ID. So here the duplicate values are there, so for that reason we are getting the error unique constant violated, and these two values are available in our table. And as we have discussed, null values are allowed in this. So insert, if I insert null, we will not get any error. One row is created, select star from test 0. This is we are getting, and that in that place we can use insert null. So clear the screen. So this is we have seen at the column level. Now let us see how can we use this at a table level. So at the table level, how can we use? So first of all, I will drop the table test01, clear the screen. Now create table test01, employee ID integer, comma, employee name, where char 2 of size 10, and we'll use unique at table level. So in the table level, what we have to do, after declaring, after, let me execute first this query, table is created. So in the at the table level, what we'll do, after declaring this column, we have to give here, we have to declare this constant and we have to give the column name, and this constant will be applicable on the combination of the columns. You will understand by the example. So let's suppose I will insert into test01 values 1 comma sam. I will insert this, it is applicable. I will use 2 ram, will not get error because at the table level it will be applicable on the combination of these both. So on the combination, one sam is there and here one ram is there. On the combination, if we see the combination, so these are different. So in this at the table level, it will see on the combination. So if I insert again this, we will get the error, unique constant is violated, because the combination of 1 and ram and 1 and ram is already available. So this will be applicable on the combination, not on the individual. So what will be the select star from test 0. So this will be the record. So make sure that whenever we are declaring the constant at the table level, it will be applicable on the combination of the column, not on the individual. So in the individual we can give the duplicate value, but not on the combination. And also we can insert the null values also, as this is a unique. In the unique we can insert the null values. One row is created. If I do select star from test 0, null is inserted. Here you can see. So we are able to insert the null. So in the unique, what will happen, duplicates are not allowed but null are allowed. And at the table, make sure that the unique constant will be applicable on the combination, not on the individual. So this is about unique constant. So next one is not null. So not null, what will happen in the not null constant, this is the second constant, that is not null. Restricted nulls but accepting the duplicate values, and not null cannot be defined at the table level. So these are the two we have to remember. It will be the restricted null but accepting the duplicate value. Duplicate values are allowed in the not null, but it will restrict the null. It is totally opposite of the unique. In the unique, what will happen, the nulls are allowed but the duplicate values are not allowed. But in the not null, it will restrict the nulls and accepting the duplicate value. And next difference is not null cannot be defined at the table level. In the unique, we are able to declare it at a table level, but in the not null we are not able to define at the table level. We can use only this not null at the column level only. So let's go to the SQL plus prompt and let us see. So I will clear the screen. Now I will drop again the table, drop table test 0 1, clear the screen. Now let us see, create table test 0 1, and I will take employee ID integer and I will take here a not null. Also employee name where char 2 of size 10, and I will take here a not null constant. So if I enter, table is created. Now if I able to insert into test 0 1 values 1 comma sam, if I insert this, it will be inserted. And if I insert here null comma sam, here we will get the cannot insert null values, because what we have done, int not null, employee ID should not be null, so null will be not allowed. So if I give here a 1 and if I give here a null, we will get the error, because null is not allowed. We are taking this not null constant at both the columns. So if we are able we are trying to insert the null, then we will get the error. So let us see, select star from test 0 1, this will be the, and we are able to insert the duplicate value. Let's suppose, so we have inserted 1 and Sam, that is already present in the table. Again 1 and Sam will be allowed. So duplicates are not allowed, but null duplicates are allowed, but null values will be restricted. So this is about not null. And next one is it can't be used at the table level. So if I see create table, first of all I will drop that table, drop table test01, clear the screen. Now if I do create table test01, employee id integer, employee name where char 2 of size 10, and I will use here a not null at a table level. I will pass here employee id, employee name, will get a error invalid identifier, because as we have seen it will be not applicable. We cannot declare not null cannot be defined at the table level, but here what we are doing, we cannot define this not null at a table level, so we will get the error. This is about not null. So we have seen the example and we are getting the same error, that is invalid. Next one is a check. So to check values with the user defined condition defining before accepting into the column. So before accepting into the column, if you want to check the values, then in that case what we will use, this check constant. So let's suppose take the example of this. So let me clear the screen. First of all I will drop the existing table test01. This is not table present, so let's create a table. Create table test01 with the employee id integer, and I will take here a salary as a number of size 10, and I will use here a check. So check the salary should be greater than or equal to 5,000. This will be the constant I will use. So in that case what will happen, before accepting the data into the salary, it will check whether the salary should be greater than 5,000. If we try to insert the salary that is smaller than 5,000, then in that case we will get the error. So let us take insert into the test01 value 1 comma we'll take 5,000. We are able to insert. What happened here, we have to give values, values 1 5,000. Why we are able to insert, because it is greater than or equal to 5,000. Let's suppose I will give here a 4,000. In that case we should get the error. So check constant is violated. Why it is violated? Because 4,000 is smaller than 5,000. So it will check before the we will insert the data. It will check is 4,000 is greater than 5,000. No, so it will throws the error, it is violated. Then again 2 and 6,000. In that case we will not get an error. So what will be the test01? We have inserted two values, and that are, I think this is test1, and that are greater than 5,000. So this is check. So to check the values with the user defined condition before accepting into the column. So this is at a column level we have seen. Now let us see how can we use this as a table level. So clear the screen. So I will drop the table, drop table test01, clear the screen. Now we will use it at table level. So I will create table test01, employee id integer, employee name, I will take here only employee name and employee salary. Employee name where char 2 of size 10, and a salary of type number of size 10. And at the table level we have to use this check. So I will give here a check. So the employee name should be lower, in the lower case, and salary should be greater than or equal to 5,000. This is a check. So table is created. Now what we are giving the condition, the employee name should be accepted in the only the lowercase character, and the salary should be greater than 5,000. So let's suppose I will insert into test01 values Sam and 5,000. We will not get here error because Sam is in the lowercase and 5000 is greater than equal to 5000, we are not getting the error. So if I give here 4000, we should get the error because check constant violated, because this 4000 is smaller than 5000, but here condition is what, it should be greater than 5000, we are getting the error. If I use here SAM, that is in the capital letter, we should get the error, check constant. So if I give here again 6000, so we are getting the error, check constant violated, because what we have done here, employee name should be in the lowercase, but what we are doing, we are giving the employee name in the capital letters. So for that reason we will get the error, check constant is violated. So we should give this in the small letter, then in that case it will be accepted. So here you can see one row is created. Now if I do select star from test 01, so Sam 5000, Sam 6000. So this is we use at the table level, we declare this check, define this check as a table level. So in that what we have seen, the employee name should be in the lowercase and salary should be greater than 5000. If any one of the condition is false, in that case we will get the error, that is check constant will be violated. So this is a check constant. Then this primary key is very important, and the foreign key and primary key are most important in this constant. So it is a combination of unique and not null nature. So whatever we have seen unique and not null, it is a combination of that. It restricted duplicates and null. So in the unique what will happen, duplicate are restricted, so duplicate restricted, and not null, that is nulls also are restricted. A table is having only one primary key. So at the column level, what, how can we declare, let us see the example. So let me clear the screen, I will drop table test 01, and let's create table test 01. I will take employee ID integer, and we have to give here a primary key. I will use here a primary key, employee name. So what we have discussed here, a table is having only one primary key, so we can't take more than one primary key. So if I do here varchar 2 of size 10, I will give here 2 times primary key. So we should get the error here. So table can have only one primary key, so only one primary key we can take, not 2. So table is created now. So insert into test 01 values 1 comma Sam, we are able to insert that. 2 comma Ram, we are able to insert that, but before that we will use select star from test 01. So if I insert again these two John, we will get the error. Why we will get the error? This employee ID is the primary key. In the primary key, duplicates are not allowed, but we are trying to insert these two as a duplicate in this, so we will get error, unique constant violated. And if I do here null, null, null is also, so here you can see cannot insert the null, as this is a primary key. In the primary key, not duplicate values and null is not allowed. So if we try to insert that, we will get error, cannot insert null into this, and unique constant violated. So this is about the primary key at a column level. So at the table level, how can we use this? Let us see. Clear the screen, drop table test 01, clear the screen, create table test 01, employee ID integer, comma employee name, varchar 2 of size 10, primary key, employee ID and employee name. This is as a table level. Table is created. Now what we have discussed, at the table level, it is applicable on the combination of both of the columns. So now I insert into the test 01 values 1 comma Sam. We are able to do that. If I do 2 Sam, we are able to do that. If I do 1 ram, we are able to do that. Now select star from test01. Will not get error because what, these are duplicate. You might be thinking we should get the error as these are duplicate, but at the table level this primary key constant will be applicable on the both, on the combination of both columns. If we take a combination, we can see that all the combination are different, so that's why we are not getting the error. So if I insert again 1 and ram, 1 and ram combination is already present. If I able to do that, we should get the error. So here you can see unique constant violated. So on the table level, if we define this primary key, it will be applicable on the combination of the column, not on the individual. So this is a way we can use primary key on the table level. So this is example, 1 ram 1 raja we have seen. When we apply primary key constant on multiple columns, then it is called as composite primary key. So it is also called as a composite primary key when we apply primary key constant on multiple columns. Next one is foreign key. So foreign key is used to create a relationship between the two tables. So let us suppose we have one employee table. This is the employee and department table. So let's suppose this is department table and this is employee table, and we have here department number, department name, here we have employee ID, employee name, DPT number. So here we have 1 ram 10th department, 2 Sam, he is also working in 10 department, 3 John, he is working in 20 department, and we have here 10 department as Dev, 20 department as QA. So let's suppose this is a parent table, this is a child table, and this is a primary key and this is a foreign key. So foreign key is used to create a relationship between the tables. So we are creating a relationship between this table. Why we are creating relationship between this table? So let's suppose this department table is not there, then what we have to do, we have to create employee table, right? In that we have to store 1 ram. As we are not creating department table, so we have to use here a 10 and its department Dev in the same table, that is employee. Again we have here a Sam, again we have to use 10 Dev department, 3 John, 20 QA. So here we are able to see this is a data duplication of data. So if there are 100 employees that are working in department 10, then we have to write this 100 times, which is totally unnecessary. Instead of that, what we can do, we can create one another table department. In that we can give department number and its corresponding department name, and we can only use the department number corresponding to employee ID. So instead of using this again and again, what we can do, we can create another table and we can create a relationship between these two table, and we can only use this department number. So what will happen, 1 ram 10, so it will refer to this department table, and 10 department, its corresponding department name will be Dev. Sam will be working in Dev department, John will be working in 20 corresponding QA department. So this is we are creating a relationship between these two. So for that reason we use the foreign key. So this, in this relationship we'll take one table, that is this, whatever table we have in the whatever table we declare define the primary key, that will be taken as parent, and whatever table that define the foreign key, that is taken as child table. So we can understand. So prime minister of one country will be foreign minister of another country. So this prime minister will be foreign minister of another country. So this primary key will be foreign key for another table. So to create a relationship between tables, we use the foreign key. And what are the rules we should use while declaring foreign key? So common column name, same name is recommended. So common column should be there whatever in those table. So we are using this department number and department number. This is recommended to take the same. Next one is common column data type must be matched. So data type of this column and this column should be matched and compatible. So if there is a int, it should be int, then char varchar, as this is a compatible char and varchar. Int varchar 2, it is not compatible, so we will get error in that case. One table should have a primary key and one table should have a foreign key. Primary table is known as parent and foreign key as child. Foreign key column values must be primary key column values. So whatever the column values present in the foreign key, that should be present in the primary key. So you can understand that if there is no department, so let's suppose we have taken the record with the 40 and this department not exist in the company, so we should get the error. So this is also one of the use of foreign key. So if we try to insert the values that are not present in the primary key of one table, then we'll get here a error. And in the this foreign key, duplicates and nulls are allowed. So in the foreign key, duplicates and nulls will be allowed. You will understand by one of the example. So I hope you understand why we use the foreign key. So to create a relationship between the two tables, and what are the common rules? The same name is recommended to take in the both the tables. The data type should be matched. One table should have primary key and another should be have foreign key. Foreign key column values must be present in the primary key. So if we take the values that are not present in the primary key, then we will get error. So in this case, you can see if we take 40 and this 40 is not present in primary key, so we will get the error. And last one is by default foreign key column is allowed duplicates and null values. So in the foreign key, duplicates and null values are allowed. So let us see the example of the foreign key. So clear the screen. We'll drop the table. First of all, drop table. So we'll create a table, create CREAT table, department 01, department number, integer, department name, I will take here as a primary key, department name, varchar 2 of size 10. Table is created. Now we'll insert data, insert into department 01 10 comma QA. What values we have to take here? Values 20 comma BA. Now this department is created. Now I will create another table with the foreign key. So how to create a foreign key? We have to use this reference. So I will copy this. So create a table employee 01 with employee ID integer, employee name varchar 2, this is data type, and this department number column we have to take as a foreign key. So department number integer, its data type, reference is department 01, this is a table name and this is a table column. So we have to take this as a foreign key. So for that we have to use this references from which table, from the department table. On which column? On department number column. So this is the way we can declare a foreign key. So table is created. Now I will insert data into this. So insert into emp01 101 101 Sam, and department number 10 is 10 is here we have to use values. So this will be inserted, one row created. So select star from department 01 emp01. So department is a parent, in this department number is a primary key, and this employee 0 1 is a child, and department number is a foreign key. Now if I insert here the data 40, we'll get the error. So integrity constant violated, parent key not found. So as we have discussed, whatever the value we are inserting, that should be present in the this primary key. So this 40 is not present in this primary key, this primary key column. So we are getting violated, parent key not found, integrity constant violated, parent key not found. And duplicates are possible, so I will 1 not 2. In the foreign key duplicates are possible, Ram 10. So we are able to create. If I give here a 20, John 3, this is also loud. So I will give employee 01, select star from dpt 01. Now null also allowed in the foreign key, so we'll try to insert that. So 104 Raja, I will give here a null value. So if we do select star from emp0, null is also allowed in the foreign key. So this is about the foreign key. We have created two tables, that is select star from department 01 and employee 01. This is a foreign key, this is a primary key, and this is to having the relationship between them. But now what I have to do, I have to delete this department from the department 01. So delete from department 01 where department number equals to 20. We'll get the error. What is the error? Integrity constant violated, child record found. So if we are deleting the data row from the parent, we'll get the error. Why we'll get error? Because these two tables is having the relationship between them. So if we delete this, then there will be the ambiguity. So let's suppose if we delete this, then if any user came and he is having the 20 department, and if we see, he see what is the corresponding department name corresponding to 20. So if we deleted this, then we will not get the this corresponding 20 department name. So there will be the ambiguity. So for that reason, we will be not able to delete the record from the parent table. We will get the error, integrity constant violated, child record found. So its corresponding child record is available, so for that reason we are not able to delete that. So while creating the foreign key, we have two rules, that is this insertion rule and deletion rule. So we cannot insert values into child table that are not present in the parent table, as we have seen. And next important rule is deletion rule. So in the deletion rule, we cannot delete the parent table data which was existing under the child table, without addressing to the child. So this is the same example. If we are trying to delete department number 10 from this department, we will not able to do that without addressing the to the child. But there are two ways by which we can delete parent table data also. So we can delete the parent table record present in the child with addressing the child. Without addressing the child we are not able to do, but with addressing the child we will able to do. So there are two ways by using the on delete cascade, and next one is the on delete set null. So let us see on delete cascade. So once we deleted the data from the parent table, then child data is also deleted automatically. So what problem we are getting? We are not able to delete this department from the parent table, but we can do by using the on delete cascade. So in the on delete cascade, what will happen? In the on delete cascade, if you use on delete cascade, then we are able to delete this data. And what happen, if this data is deleted, then its corresponding child data will also be deleted. So if we delete this also be deleted. So let's say see the example on delete cascade. So I will drop the table if table is available as table not available. So we will create one table. Create table department 02 department department number integer, department name varchar 2 of size 10, and this we have to take as a primary key, department name varchar 2 of size 10, department 2 will be created. So I forgot to take here on delete cascade. So the on delete cascade will be taken in the child table. So first of all we will insert the data, insert into department 02 values 10 QA and 20 dev. Now this is created. Select star from dpt 02. Now we will create another table, that is child table. Create table. I have here a syntax, let me take that. Where is on delete? So this is a syntax for using this on delete cascade. Let me copy this, go here, and I will paste here. So I will zoom in little bit. So here this is a foreign key, that is department number, references department 02, and here we'll use on delete cascade. So this is the extra one we are using, on delete cascade. So this is department number is the foreign key, references from department 02, the column is department number, and on delete cascade. So let's execute this. Table is created. Now I will zoom it, clear the screen. So let us insert data into the employee 02. Insert into emp02 values 1 Sam, and he is working in 10th department. Now 2 Raja, working in 10. 3 Brock, working in 20. Clear the screen. Now I will use select star from dpt01. Sorry, we have to use here a G department 02 emp02. So these are the two tables we have created. But here what, while creating this table on the foreign key, what option we use? On delete cascade. Now in this case, if you want to delete the record from the parent table, so its corresponding record in the child table also deleted. So let's suppose I want to delete this, then its corresponding to department 20, this will be also deleted from the child table, because we are using here on delete cascade. So let's suppose I will use delete from dpt02, where dpt number equals to 20. So one row is deleted. So if I go here, corresponding 20 row is deleted, and if I go to the so here we go, corresponding to department 20 is also deleted in employee 02 and also in the department 02. So in the department 02 we are deleting this 20, its corresponding row in the child will also be deleted. Here we go, there is no department number with the 20 in the child table. So this is the way we can use on delete cascade. Next method we have is on delete set null. So in the on delete set null, what will happen? So if we try to delete this record from the parent table, this, then what will happen? Its corresponding record in the child. So here what will happen? At this 20 place, here it will take a null value. So at this 20, what will happen? It will be replaced with the null. So this is about on delete set null. So on delete cascade, in that what happen? It will be removed, and also its corresponding row in the child will be removed. But in the on delete set null, this row from the parent will be removed, and is corresponding whatever the employee working in that department, in that department number place, null value will be placed. So this is about on delete set null. So let's see the example for this. So again I will create a new fresh 2 tables. So create, let me see, first of all describe test department 03 is available, no. So we'll create that. So create table test department 03 with employee ID integer, employee name. First of all we have to take here as a primary key, and employee name varchar to of size 10. Table is created. Now I will insert the data, insert into department 03 10 comma dev. What happened? Values we have to take, right? Values, and 20 comma qa. So this table is created. So select star from dpt03. Now it's time to go for the what on delete set null for the employee 03. So this is, let me copy this and go here, paste here. So let me zoom in little bit. So if we see the employee 03 table, it is a child of this department, employee ID, employee name, department number, and this we are taking as a foreign key. So we have to use references from department 03 and which column, department number, and here we have to use this on delete set null. That means whenever we delete department number specific, so in the child table it will be taken as set as null. So let us create this. What happened? Oh, I take here a name as employee ID. So I have to rename that. Let me see, alter department 03 rename. I have to use alter table department 03 rename EID to department number. Let us see what happened. Here you have to rename column 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 EID to department number. I think this is correct. Yes. And employee name I have to take here as a department number. So also employee name in that table I have to take as a DPT name. By mistake I have taken other name, so now it is resolved. I think select star from DEPT03. So the name is changed now. Now this time to create for child table. So there, yes, this is the syntax. So now table is created. So this child table employee 03 is now created. Now it's time to insert a data into this employee 03. So insert into emp03 values 1 Sam working in 10 department, 10 Ram 2 he is working also in 10th department, 3 John 30. Let me take 20. Now clear the screen. Now we'll select also from the employee 03. So these two tables having the relationship between them. This is a primary key, this is a foreign key. Now if I want to delete record from this corresponding to this, so after that what will happen, whatever corresponding here that will be null and here will come null. So let us try to delete that. So delete from DEPT03 where DEPT number equals to 10. One row is deleted. Now if I able to, so here 10th record is deleted. Now if I go and select from employee 03, so here we go, here we are getting the null because it is corresponding in the parent table record is deleted. So we are getting null because at the creating of this employee 03 we have used what, on delete set null. So if I go here, this is the syntax, on delete set null. So after removing this parent, the child in the child it will come as null. So these are the example we can do practice with the example. So first we seen, let me go above. So this constant we have covered in this unique. In the unique what will happen, duplicates are not allowed, not null. In the not null, null are restricted. In the check, before accepting the data, we if you want to check, then there we will use check, then primary key, unique and not null. In the foreign key, to create a relationship between the between two tables. So these are the important constant we have seen and their example. So if you like this video, you can hit like button and subscribe to our channel. And I have already created videos on other concept in the SQL, that also you can see. I will give the link of the playlist in the description.